So this is the 2015 Leave Insert Ordinary Level Paper 1 and we're looking at question 7. The first 3 patterns in a sequence of patterns are shown below. So we have the patterns here, patterns of triangles, black and white. Part A says draw the 4th pattern in the sequence. Okay, so we can see what's happening here each time we're adding an extra layer to the bottom of the pattern. So we've this on top of pattern each time, and then we're adding another layer underneath. You see that's in all of them. So we're going to start by drawing that and then adding the layers to that. So we can draw our pattern at the top. So there we have our pattern of 4. Then we've got this layer underneath. We continue those lines down, drawing them back up. So that's this one. Then we're adding another layer. Again, we continue those down. So now we've got this one drawn, and now we're just going to add one more there. Whatever way you decide to draw this is okay. We've got the solid ones coloured in. So we can see now we've got this extra layer of 5 dark ones along the bottom and the 4 clear ones. So that's the 4th pattern drawn. Okay, part B says complete the table below. So we've got 1 column for the number of black triangles, 1 for the number of white, and 1 for the total number of triangles. So for the black triangles, if we go back, the pattern for the black triangles is we've got 1, 2, 3, then we've 6 here, 10 here. So that's for black, it's 3, 6, 10. Pattern 4 has 10 plus 5, which is 15. Right, that's a 10 there. So we can see the pattern as we're moving down then. We haven't drawn pattern 5, but we can see we're going up 3, up 4, up 5. So now we're going to go up 6, so that means this would be 21. And then we're going to look at the white triangles. So we've got 1, 3, 6, and then here we have 10. So 1, 3, 6, 10. So 1, 3, 6, 10. And again here you can see we're going up in 2, up by 3, up by 4. So now we're going to go up by 5. So that would be 15 for here. And then we're going to look at our total number of small triangles. So that's the black and the white together. So when we add 3 and 1 we get 4, 6 and 3 gives us 9, 10 and 6 gives us 16, 15 and 10 gives us 25, and 21 and 15 gives us 36. So there's our table filled in with all the pattern numbers. Part C says show that the number of black triangles form a quadratic sequence. So let's write our black triangle sequence out. The black was 3, 6, 10, 15, 21. So 3, 6, 10, 15, 21. Okay, now a quadratic sequence, if you have a quadratic sequence, it means the second difference is constant. Second difference is constant. So we're going to show that that's the case. So the difference from 3 to 6, that's a difference of 3. From 6 to 10, that's 4. From 10 to 15, that's 5. And from 15 to 21, that's 6. So now we're going to look at the second difference. From 3 to 4, that's 1. 4 to 5, that's 1. And 5 to 6, that's 1. So we can see there that the second difference is constant. So that's these numbers here. Second difference is constant. Part D says, how many black triangles are there in the 9th pattern? How many black triangles in the 9th pattern? Then how many white triangles are in the 9th pattern? And how many triangles in total are in the 9th pattern? So if we go back here and just continue the sequences up to the 9th pattern. So pattern 6, 7, 8, 9. Okay, so we added 6 here, so we're going to add 7, that gives us 28. Then we'll add 8 to that, gives us 36. 9 to that gives us 45, and 10 to that gives us 55. Here we're going to add 6 this time, that gives us 21. Add 7, 28. Add 8, 36. And add 9, 45. So then our total then will be 55 and 45, which will be 100. So 55 for the black, 45 for the white, and 100 for the total. 55, 45, and 100 in total. Part E says write an expression in n for the total number of triangles in the nth pattern. So we want Tn, or the nth term, for the total number of triangles in the pattern. So if we go back and have a look at this, we're looking at these numbers here. And we're trying to link these numbers somehow to the pattern number, because this pattern number here is the n. The pattern number is the n number, so this is our n value. So the first thing you should recognize is these numbers here, these are the square numbers. 4 is a square number, 9, 16, 25, these are all square numbers. So that's the first thing to notice. 4 is equal to 2 squared. 9 is 3 squared. 16 is 4 squared. And so on, right? All the way down. So we can then maybe try and link the base of each of these to the pattern number. So how do we go from 1 to 2? Well, we just add 1. How do we go from this 2 to this 3? We add 1. This 3 to this 4, we add 1. So really we're adding 1 to n, and then we're squaring it. So we're adding 1 to the n. N is the pattern number. We're adding 1 to that, and then we're squaring that. So that's the nth term for the total number of small triangles. N plus 1, and then we're squaring that answer. That's Tn for the total number of triangles. Part F says the number of black triangles in the nth pattern is given by the formula Bn is equal to a half n squared plus 3 halves n plus c. Find the value of c. Well, if we go back here, we can see for the black triangles, pattern 1 has 3 black triangles. So we can say, if this is the case here, if Bn is this, well then B1, we know that that's equal to 3. But we also know that B1 will be equal to a half. If Bn is a half n squared plus 3 halves n plus c, well then B1 will be equal to a half 1 squared plus 3/2 of 1 plus c. So when we tidy that up, we get 1 squared is 1, a half of that is a half plus 3/2 plus c. So a half and 3/2, that's 4/2, which is 2. So we end up with 2 plus c. So what we have then is that b1 is equal to 3, but also b1 is equal to 2 plus c. So then we can just say that 2 plus c must be equal to 3, if those two things are the same. If b1 is 3 and b1 is 2 plus c, well then 2 plus c must be equal to 3. And if 2 plus c is equal to 3, that must mean that c is 1. So that's the answer to part F. Part G says use your answers to part E and F above to find a formula for the number of white triangles in the nth pattern. Okay, so we're looking for the number of the nth term for the white. So we'll call that Wn. Now we know that Wn plus Bn, the nth term for the black patterns, we know that's equal to the nth term for the total patterns, which from part E was this n plus 1 squared. And we know that Bn, we have that already, so Wn plus, if we bring this Bn over first, here it becomes a minus Bn, minus the nth term for the black pattern. So Wn will be equal to n plus 1 squared, which is n plus 1 by itself, minus Bn, which we have up here. Bn is a half n squared plus 3 over 2 n plus c, but we now know that c is 1, so plus 1. So Wn is equal to, we can multiply these brackets out, n by n is n squared plus 1n plus another 1n, that's plus 2n, and then 1 by 1 is 1, and from that we are subtracting Bn. So when I was subtracting Bn, I should have protected all that Bn in brackets, so it's minus all of Bn. So what I get then is minus a half n squared, minus by plus is minus 3 over 2n, and minus by plus again is minus 1. So when I look at this a bit closer now, I've got n squared minus a half n squared. I've got 2n minus 3/2 of 2n. And I've got plus 1 minus 1. So when I'm tidying that up, n squared minus a half n squared, that's just a half n squared. So full n squared minus a half n squared is a half n squared. The greens now, 2n minus 3/2 of n. So 2 minus 3/2, you could do this on a calculator, but 2 minus 3/2 is just a half. So that gives us a half n. And finally, the blues, 1 minus 1 is 0. So Wn, the nth term for the white triangles, is a half n squared plus half n, and that's my answer. Okay, so finally, part H. One particular pattern has a total of 625 triangles. Find the number of black triangles and the number of white triangles in that pattern. So the pattern that has a total of 625 triangles, well, the nth term for the total is n plus 1 squared. So we know that that total is 625 for this pattern. So if we're going to find the number of black triangles and white triangles in the pattern, let's find which pattern it is first of all. So let's find n. So if we look at this equation here, we can square root both sides. So we would get n plus 1 is equal to the square root of 625. So we find that n plus 1. Now we can ignore the negative here. Square root of 625 could be plus or minus 25, but we know that n is going to be, it has to be positive, so we can ignore the negative one. So it's just 25. And we bring the plus 1 over here, it becomes a minus 1, so we forget finally that n is 24. So it's the 24th pattern we're considering, and the question is find the number of black triangles. So we're looking for B24, and then after we'll do the white triangles. So B24, that's going to be equal to a half of 24 squared plus 3 halves of 24 plus 1. And when we work all of that out in the calculator, we get 325. So that's the number of black triangles. B24. And then we also want the number of white triangles in pattern 24. So that's the nth term here that we just figured out for Wn. So that's a half of 24 squared plus a half of 24. And when we do that in the calculator, we get 300. And that's the end of the question.